Okie dokie, welcome back to video 2 where we're going to concentrate on subtracting our linear expressions. And you took some notes from the top of page 89, and in there you should have refreshed in your mind the subtraction rules for integers because they apply to everything, even expressions. So here we go. Subtracting integers, what do we say? Change to adding the opposite, the additive inverse. And some of us even remember same, change, change. So what I'm going to tell you, you need to write down so you really know what we're talking about. When you change to adding the opposite, comma, you must. I'm underlining must. You must change the sign of every term. Underlining that, every term in the second expression. Let's make that neat. In the second expression. All right? So if you need to, pause this, get it all written down, and then join me as I go forward. Here we go. Subtracting linear expressions. Find the difference. So I'm going to go back to that last definition of the rule for subtracting integers, same, change, change. And I'm going to write same, change, change. Because everything in the first expression stays the same. Subtraction changes to addition, and everything in the second expression changes signs. So what do we have? We have negative 3x plus 7. That stays the same. Subtraction becomes addition. Our positive 4x becomes negative 4x, and our negative 8 becomes a positive 8 as we change every sign. Now, we're left with what we just learned how to do. Adding, which means what? Combining like terms. So we take our negative 3x and our negative 4x, and we say negative 7x. We take our positive 7 and our positive 8, and we say 15. So negative 7x plus 15. Now, ladies and gentlemen, for those of you who like to do things horizontally now, I'm going to practice this one. I'm going to show you how to do it horizontally. So when you're rewriting, you just rewrite it in the horizontal form. So again, we're going same, change, change. And I'm going to keep the first one the same, negative 3y minus 9, keeping that one the same, plus, I'm changing that subtraction to addition. And now I'm going to write the next one after changing the sign. So negative 9y becomes positive 9y, and a positive 6 becomes a negative 6. Now I can just add up, going straight down. A negative 3 and a positive 9 is 6y, and a negative 9 and a negative 6 is negative 15. So 6y minus 15. And oh, just in case you were thinking, yes, there are times that we will have to distribute to simplify first, and before we can do anything, because this expression is not simplified yet. Even though it will stay with the parentheses on it, it stays with parentheses only to identify it as a different expression than the first one. All right? So now we have to go negative 3 times 2, which is negative 6y, and negative 3 times a negative 9 is a positive 27. So the only reason I put parentheses on there was to separate it so I knew that I was taking that expression and subtracting the second expression, 5y plus 4. Now, what are we going to do? We're going to do our same, change, change. And we're going to say negative 6y plus 27, keeping the first one the same, changing that subtraction to addition, and then changing the sign in every term. That becomes a negative 5y and a negative 4. Lastly, all we have to do is combine like terms. We have a negative 11y, and we have a positive 23. Ladies and gentlemen, pretty straightforward. If you are paying attention, you will find that this stuff gets easier. But you got to pay attention and really master what we're doing before as we move forward and using the same stuff over and over, applying it in a different way. Let's go to our real life application. It says the original price of a coffee table is D dollars. You use a coupon and buy a table for D minus $4. You paint and sell it for 3D plus $1. Write an expression that represents your earnings from buying and selling the coffee table, and then interpret the expression. So you're going to make money, right? You wouldn't buy it, then paint it all up and make it nice, and then sell it for less than you paid for. You'd be losing money. That wouldn't be smart. So you know that what you sold it for is more than what you bought it for. So to find how much you earned, you would take your first expression, what you sold it for, 3D plus 1, and you would subtract what you paid for it. That's D minus 4. And then what do? That's right, we go same change. 3D plus 1, and then adding a negative D plus 4, and then we combine our like terms, and we have 2D, and we have plus 5. So this is our earnings. Oops, I-N-G-S. I can spell once again. Even though it is math, and I have trouble spelling, I can still spell. So 2D plus 5, to interpret that expression, that is our earnings after we painted it and sold it. Ladies and gentlemen, that's the end of this second video. Your quick right, and the only part is to subtract these two expressions. You might want to pause when I'm done talking and get that written down as you go. Take a break, stop your clock, start it again when you come back for video number 3. See you in a